So we're just gonna get into things. Good morning, everyone, and welcome to another session in our webinar. I just want to thank you for joining us today for what promises to be an insightful and engaging session on the power and precision of EOS GNSS receivers. Whether you're a seasoned professional in GIS surveying or UAV data collection, or simply curious about advancing your geospatial capabilities, you're in the right place. Today, we have the pleasure of hearing from Steve Lawrence, Global Sales Manager at EOS Positioning Systems. With over 20 years of experience in GPS and GNSS technologies, Steve brings a wealth of knowledge and real-world expertise across diverse sectors, including utilities, infrastructure, natural resources, and municipalities. In this session, Steve will introduce us to EOS's cutting-edge SCADI and Arrow series receivers, devices designed to deliver sub-meter to centimeter level accuracy on any mobile platform, including iOS, Android, and Windows. We'll explore how these affordable, high-performance tools integrate seamlessly with your major data collection apps to help you capture precise, high-quality geospatial data in the field. We're also pleased to have Everett Johnson joining us as a panelist today. Everett is a GIS professional and surveyor here at Spatial Innovision, and he'll be lending his insights and expertise to support this discussion. Throughout the session, we encourage you to drop your questions in the chat or to use the Q&A feature. We'll be sure to address them during the Q&A segment. So, without further ado, let's dive in and discover how EOS Positioning Systems is empowering professionals like you to work smarter, faster, and more accurately. Steve, over to you.
Thank you, Camisa. That's a wonderful introduction. So to recap that, my name is Steve Lawrence. I am the Global Sales Manager for EOS Positioning. This has been a fairly long journey in this industry, and it's been more than fun over the last several years, especially recently with all of the technology advances that we've been able to make in the industry. And we'll touch on a few of those. And as Camisa had said, we will have, at the very end, we'll have questions and answers. We'll have a overview of our hardware. I'll show you what we offer with the Arrow and the Scotty. I'll give you a solution overview, how you apply it in the field. We'll talk about the advantages of using our hardware, and we'll talk about the benefits of the Arrow and the Scotty. And then I'll show you some of the functionality and integrations that we've designed over the last 15 years. So we are a Canadian designer and manufacturer of GNSS hardware. We have an international presence through distributors and dealers, such as Spatial Innovations. Our team built the first Bluetooth GNSS receiver that's device agnostic, meaning that you can use whatever device you would like, such as a tablet or a phone. We have hundreds of years of experience. For a small company, most of us are at least 10 years in the business. We're a leading provider of the bring your own device market. And as Camisa alluded to, we service all of the industries. It's easier to list the ones we don't touch on rather than list all the ones that we do. But it's infrastructure, water, wastewater, municipalities, natural resources, oil and gas, anything that needs a position, essentially. Our focus really is to bring high accuracy data to those GIS users. Our staff here in Terrebonne and in Montreal, or just outside of Montreal, includes R&D, manufacturing, technical support, sales, and marketing. The business pains that we solve are that all clients have assets of some type. They can be trees, water valves, lines, sidewalks, garbage cans. Most of the clients that we serve have this information somewhere. It could be in a GIS already, it could be in CAD drawings, it could be on paper of some type. Most often in smaller areas, we find that it's in somebody's head, so they remember where everything is. The biggest challenge that we have with these pains is to educate customers that there's a better way to manage all of this information. And having a successful deployment using high accuracy GIS brings that to the front and allows them to make better decisions, gives them more accuracy as to where everything is. And really, when you look at it, without that, they don't know where anything really is, whether it's above ground or below ground. So how do we solve all these problems? Well, we first answer the question of what is it? So in this photo, you can see that it's a natural habitat with turtles. And then we answer the question, where is it? So where is it on the face of the earth or in my community or in my area? Our product line to do this, first we have a single frequency sub-meter receiver. We have the Scotty 100 and we have the Arrow 100. We then move up to a dual frequency RTK receiver, being the Scotty 200 and the Arrow 200. We now move to a triple frequency system, which is the Scotty 300 and the Arrow Gold. And we have one more. Keep in mind, we're a worldwide company, so we offer something for all frequencies, including E6, so Galileo has, with the Scotty Gold and the Arrow Gold. The last three, the 200, 300, and Gold, are capable of centimeter accuracy. So if you are connected to a base station, if you have one, or you have access to an RTK network, you can have 2 centimeters accuracy, X, Y, and Z. The solution overview is that we only provide you with positional information. We don't offer software. So you would look to somebody like Everett at Spatial to find the best software available, which is typically going to be, in our case, Esri based. Our accuracies will range for your data from sub-meter to centimeter. And again, keep in mind, you can use whatever you want. You can have an iPad today, you can have an Android phone tomorrow. You could have a Windows tablet. The advantages of our hardware, being the Arrow and the Scotty, what we offer is a lower operational cost. We don't require any post-processing. We don't require any annual software maintenance or subscription, again, subscription fees or maintenance and support fees. When you buy the product, all of your maintenance, all of your support is included. We give you the ability to choose whatever you want from hardware and software. We do offer mostly Esri-centric value solutions, such as EOS Locate, EOS Laser Mapping. Everything is field ready, so as Esri changes, we're up to speed, and it's what they term as release ready. We support all types of real-time corrections from SBAS to RTK to Galileo HAS to Atlas. And again, all offering you ranges of accuracy without having to post-process. So at the end of the day, the data is what the field user has seen and passed to the inside person. Again, we have integrated workflows with Esri. We have integrated workflows with many different apps that are out there. So you don't have to use just one. You can use whatever suits your requirement. What I like to tell people is our support and our service is where we excel. We're able to do this very fast, very quick. We have 8 people doing support now. So you're rarely at a spot where you're stuck and you're on your own. To do this, we have our utility is EOS Tools Pro. It's for Android, Windows, and iOS. And what it does is it overrides the location services or the mock locations of your device. It allows you to connect to an Arrow or a Scotty receiver, and it handles all of your RTK logins. So when you're using it, you basically set everything up inside of EOS Tools Pro, and that will push your data right to whatever app you're using. It also looks after EOS Locate, EOS laser mapping, orthometric heights, and we'll touch on how it works with the tilt compensation in the new Scotty and the smart handle in the new Scotty. Where our hardware really differs from your traditional units is we use all four constellations in the calculation of the position. What this does is this gives us roughly 3 times the number of satellites available to a GPS unit, 2 times the number of satellites when you're looking at something that is GPS and GLONASS. And it also allows us to have longer baselines when using RTK corrections. So for instance, traditionally you're limited to roughly 40 kilometers before you start losing or having degradation in your accuracy from 2 centimeters up to 3 or 4. We can actually go towards 80 kilometers before that happens with using 4 constellations. And from the attached screenshots, you can see there, with GPS, we're running 10 satellites. With all 4 constellations in the same spot, we have 31. So what that means is when you get into canopy, I start out with more satellites. We're going to lose them at the same rate. But if the GPS unit loses 5, they don't have a position. If I lose 5, I've got 26 to play with. So again, benefits and features, you choose what you want to use. From hardware, from software. You're not restricted or not forced to use something that on your product, on your device. You can use whatever you want. This gives you reduced operating costs. You can choose a free app if you want. You can choose a paid version. Okay. So again, when you look at the 3 items that are the biggest for us, there's no subscription fees, there's no maintenance fees, there's no support fees. So traditionally, you would buy a product and then expect to pay roughly 10% in fees next year. So when I look at it, I think that's a huge benefit for us because you know that you've made one purchase and you're not going to have to continually pay for the unit. If we start to look at where we've really opened up the market, our new product, Scotty, has a handful of features that are very, very unique. We're the first to offer tilt compensation in a truly GIS product specific for the GIS market. With tilt, there's no reason or no need to level your range pole. You can have it have it leaning when you collect the point. You also don't worry about having to calibrate your range pole because those levels will go out of spec every now and again. The IMU that we use offers 0.3 millimeters per degree. So you tip it at 10 degrees, you've added 30 millimeters of inaccuracy. So not even a centimeter. Tilt is available on all of our RTK models. So if you think back to the slide where we had all of the products listed, anything that is RTK, so the 200, the 300, and the Gold. When we look at EOS Tools Pro, you can see on the left, we have the tilt compensation. On the slide or the image just to the right of that, you have a shot of field maps. You can see your location. But the takeaway here is look at the tilt quality and the tilt angle. So I'm tipped at 19 degrees and I'm 0.002 meters for accuracy, where that point is. So I'm going to take my accuracy of the receiver, which is about 2 centimeters, and I'm going to add 0.002. You'll see the range pole height. You'll also notice we offer the ability to restrict how far over the user can tip it at 60 degrees. We also change your quality, or allow you to change the quality threshold from 75 centimeters all the way down to 0 if you wanted. So if that user laid it down on its side on the ground, it won't allow you to collect it for one of these two parameters. When you look at the images on the right of your screen, you now see the raw data, or the GNSS data, and the compensated value. So you can see how much change in position that tip in the range pole, or tilt at 3 degrees, has added or changed your X, Y, and Z. When we move forward, we added a smart handle. So the smart handle gives you LiDAR and laser. So you'll notice in the one where it says elevation, the laser is being used here. Sorry, the LiDAR is being used here. As the user moves it up and down, the range pole height changes. So what does that actually mean for you? You don't need a range pole anymore. We're giving you a constant elevation, so you can carry it at your waist and collect data. You can carry it up at eye level and collect data. It's going to give you the reference to the ground with the LiDAR. On the other side, you'll see the user shooting the laser at a valve. Think about it. Now I don't have to tip or put my range pole on top of that. I have what's termed as a virtual range pole, and I can shoot that target up to 8 meters away at 60 degrees. So I can now spot something and shoot it and keep myself out of harm's way. So if it's a manhole on a busy street, I can stand back and aim the laser at it and shoot it. If I'm collecting a sidewalk and I'm collecting the elevations, I can pull the trigger, use the invisible range pole, and just walk that line. So again, when we look at the screenshots, our system will vibrate, and you will also have voice commands or voice responses telling you what mode you're in, telling you if it's collected the point, all of the things that make it very simple and easy to use. And again, if the takeaway on this slide is look at my extensible pole height. So if you remember back to the tilt, it was set at 2.03 meters, 2.037 meters. Right now, I've moved it from the top of the range pole to 0.99 meters. If you look at the invisible range pole mode, I am tipping the Scotty at 9 degrees, and my range pole, or where the tip would be if I had a range pole, is 2.05 meters away. Okay, that's, this is a very interesting concept in terms of the number of uses that you can have for this and the way it can be applied. Again, because I'm removing the range pole from the equation. So some very, very powerful tools that we're building into GIS, and we're feeding that to whatever app the user wants to use. So now you have a really cool product. It's very powerful, and I can still use whatever I want. I'm not forcing you or giving you a proprietary solution. If we look at the laser mapping, which I touched on a couple of times, what we've done here is we allow you to offset the position using LTI lasers, feeding that data into ArcGIS Pro or field maps through EOS Tools Pro. We, the benefits here are now I'm not in a multipath area. I can step back and get a better position and shoot that laser. So if I'm in canopy or I'm against a building, I can step away. So I'm offering users, or we're offering users, a way to collect data faster and better without having to actually go to the asset. One of the things, or one of the uses that I saw a few years ago was a city was mapping trees, and they have trees on all of the boulevards. So rather than have the user walk up and map each tree individually, he stepped back to a decent spot where he could see 15 to 30 trees and then shot each one with the laser. In a summer, which is in Alberta, is about 3.5 to 4 months, he was able to collect 35,000 trees. An astounding number when I looked at it, but it's more than doable based on these methods. So again, you can shoot directly at the asset. It can be under something, in this case, under the truck. You're not standing out there beside it trying to collect it. So you can capture multiple things from one location. We also have EOS locate. So for those of you who are mapping assets underground, like electrical lines, gas lines, water lines, anything like that, we have a solution that allows the user to use a locator like a Vivax, an RD, Metrotech, Subsite, 3M, and feed all of that data into field maps through EOS Tools Pro and into your GIS. So now you have an accurate underground map of your data. Okay, so we have a quick 15-minute presentation or demo on how to use the Scotty. The slides are great, but when you see it in action, now you can really get the power of it. So I'm going to pass it back to Camisa, and she'll run the video for us. And then we'll have as much time as we need for any questions.
All right, so we're going to take a look at the Scotty Gold in on the range pull utilizing the new tilt feature. Tilt is an activation upgrade for the Scotty Gold, Scotty 300, and Scotty 200. So any of the RTK enabled Scotty receivers you can use tilt with. So the first thing we're going to do is we're going to mount this on the range pull. There's a clip at the top here that will fit right into the grooves. Get that locked in. We'll put it back in my stand for now and power on the receiver with the power button on the side there. Then we need to pair our device via Bluetooth. So this could be an iPad, could be an Android device, or a Windows device. See the Scotty Gold show up in my other devices, and then the number is related to the serial number. It's on the bottom of the receiver. So I'm going to pick on that to connect. It says it's connected, and we'll flip over to EOS Tools Pro. EOS Tools Pro is the companion app that is the app for interfacing with the Scotty for two primary purposes. One for giving you detailed information about how it's performing, and also to stream RTK corrections. So we've got a base station operating here on the building. I've gone into the differential settings here, got connected, and looking at the upper left, we can tell that we have a fixed position. Okay. If you look at the upper right of EOS Tools Pro, it says tilt compensation and then disabled. So it's not on by default. There's two ways to turn it on. Either press the power button 3 times to toggle it on, or click on that icon there and then toggle tilt compensation on. First, let's see what this looks like in field maps without tilt. So here's field maps map of our office here where I'm standing. And so let's set our location provider to EOS positioning systems. I'm going to leave the antenna height at 0 because that's a crucial for tilt. Even though this particular demo is going to be not utilizing tilt quite yet. So we'll come back to that. Select my device, done. Okay. So here we are, we got our position in field maps. GPS accuracy is just under a centimeter. And so this is operating just like Arrow Gold, Arrow 200, any of the Arrow RTK receivers. It's operating the same way. And what I mean by that is if we go to the top of this parking lot line here, and I bubble up the range pole, it's relatively close to the end of that line. Now, as I tilt it, you can see my position follows the antenna and not the tip of the range pole. So that makes it crucial that when you collect data this way, that you are completely level, utilizing your bubble level. Now with tilt enabled, let's toggle that on here.
Tilt initialized.
Tilt requires RTK because it's using RTK to calibrate the IMU inside of the Scotty. So at first, if you don't have RTK and you kick it in, it may ask you to shake the range pole. So you just move it a little bit. And then once the tilt compensation badge goes green, it says enabled, then it's compensating your position no matter how much you tilt that range pole. So now let's take a look at field maps. Move over to our line. So I put the tip of the range pole at the end of that line. First start out with it leveled. Okay, we're close. Now I'm going to start moving, tilting the range pole, and my position is staying in the same spot. That's what we want to see. And even to the extreme, I wouldn't recommend using it this way, but we can pretty much lay down the pole and it is staying in that position. So it's really flexible and allows you to collect data more efficiently, but also in tougher places. So here's an example, a couple examples. Say I was mapping out this parking lot line. I would go grab the end of this line here, capture it, and then come back over here. And with the vehicle in the way, I would normally not be able to capture the other side of this line, right? Because I would have to level the pole, which means this is about as close as I could get, about a foot away. But even with this car here, I can see the line. I can put the tip of the range pole on the line and hold it at about a 45-degree angle and still capture that point accurately. And if I zoom out a little bit, you can see our position is landing right at the end of that line. So that's one scenario where that can help. There's lots of similar scenarios where cars are parked over manholes, valve covers, that kind of thing, and you wouldn't normally be able to collect those. Another situation is up against buildings like this. So capturing building corners or entryways that kind of go into overhangs. Well, in this situation, normally I would have to come in here, hold my range pole up, bubble, level the bubble, and now that's blocking a significant number of satellites that my GPS receiver could be utilizing. With tilt, I don't even have to climb in there. I could stand out here, get the tip of my range pole at the corner of the building, hold it out like this, and capture my point. Those are two useful scenarios with using tilt on the pole. So it's two things. It's making you more efficient. Don't have to spend the extra time to level the range pole. Less training required. That's usually the part that folks get tripped up on the most when they're first starting out using this stuff is getting that pole level in a timely manner. But also capturing points in more difficult areas that you wouldn't be able to when you have to keep that pole level. So the next thing we're going to look at is the Scotty on the smart handle. And the smart handle has a couple different modes that we're going to look at and different purposes, use cases and challenges that it solves. So this is what we're calling the shape shifting. So we're going to move from the pole setup to the smart handle. So I'm going to remove my mobile device. And I'm going to take this Scotty off of the range pole the same way I put it on. So it's spring-loaded clips. Just push it to one side and pop it off. And then we're going to mount the smart handle. So it's a two-step process. First is we need to remove the battery from the Scotty. We just use these two tabs, pull those back and remove the battery. And the nice feature on the Scotty is that it has an internal battery that will allow it to run up to 15 minutes without a battery installed. So even though I've removed this battery, the Scotty is still on and tracking, getting RTK, all of that, which allows me to install the smart handle into the battery compartment and then put the battery into the smart handle. Once I install
Extensible
that,
pole mode.
it tells me audibly that it's in extensible pull mode, which is the default mode for the smart handle. Last thing is put your mobile device in the mount. And ready to go. Let's get this out of the way here. Okay, so extensible pull mode is a combination of the GNSS receiver, the IMU for tilt compensation, and the LiDAR sensor that's in the smart handle. So by inserting the smart handle, we've added LiDAR as a capability. And what that is going to do is measure distances and angles from my GPS receiver. So extensible pull mode is kind of a directional mode. So I've got a green laser light that's flashing right underneath me wherever I'm pointing this. And while it's in this mode, it's not going to be outputting a GPS position. It's not going to do that until I press and hold the trigger that's just underneath the handle here. So as soon as I press and hold the trigger, that green laser light goes solid. And wherever I point that laser, it's going to report my GPS position to that point into field maps or whatever mapping application that you want to use. So let's look at that in field maps. Okay, so field maps is saying connecting to device because while I'm not pressing the trigger, it's not outputting GPS position. If I press and hold it, it goes solid, and field maps gets our position, shows our accuracy at the top there, 0.4 centimeters. And wherever I point that green laser is where my position goes in field maps. So I'm standing right in the middle of this parking spot and aiming that laser at the end of that parking lot line. See that there? Aiming at the other one without moving. Aiming at that one. Wherever I'm pointing this, field maps is getting my position at that point. Let's capture a couple of features. So first, a point feature. The way that we control when field maps captures the point using this new technology is by enabling GPS averaging. So I've averaging set to 2 points, and you can see there once I started collecting a feature, it's kind of stuck in this state of averaging 0 of 2. You can see at the top, and that's what it's doing is it's waiting for a valid GGA position to come through. So as soon as I press and hold the trigger, and we get valid GPS data, it's going to average those 2 points and collect the feature. So if I want to do that again, I can click start averaging. I can go to the end of this line, point at it, pull the trigger, it gets my position, and I can save that. The other way we can use this is by doing a line. And so if we do a new line feature, we could do GPS averaging, collect each vertex individually, or we can use streaming mode. So if I stop averaging, hit 3 dots, and start streaming, now I can draw, say, this curve. So I'm going to Without pulling the trigger, I'm going to aim the laser at the curb, my starting point. I'm going to press and hold the trigger. I'm going to go solid. And I'm just going to basically draw this curb directly into field maps using this laser. So this is combining, RTK positioning with that IMU tilt sensor to accommodate for tilt, and then the LiDAR sensor for distance measurements from my receiver down to the curb. So just by holding the trigger, walking along this curb and pointing at the laser at the top, I'm essentially drawing this curb right into the map. Hit submit. And you can see our new curb line. It falls pretty much directly on top of the other lines that I've captured. Another use case for this is finding features. So finding an existing feature in field maps using the extensible pull mode, we can just select a feature, do that one, and let's do the compass. And so, imagine if this grass was, 5 feet tall, or is covered with snow, or it was otherwise, inhabitable or not easy to look through. I could put field maps into compass mode. I could stand here, and using that laser, I can kind of point it around until I have a decent idea where my feature's at. Okay, I see where I'm pointing it. I can stop it, walk over there, get a closer look. And there we go. It's this corner piece of this landscaping design here. So it makes it really efficient to find features, and maybe to look in dangerous places. Maybe there's a backyard with a valve behind a fence or something like that, where you can just point the laser over that fence into the area and locate that feature.
So you've seen Scotty, you've seen our overview of how we help the GIS world and the GIS industry and users like yourself. If you have any questions, we have roughly 17 minutes for questions. Camisa, Everett, do you have anything you would like to add?
I'm not presently seeing any questions in the Q&A, but it's my assumption that the presentation was pretty clear. It was quite insightful. I actually really enjoyed the video. But there's no need to be shy, guys. If there's anything that you guys are unclear about, anything you want to ask of Everett, of myself, of Steve, about the Scotty systems, you just let us know. Okay, well, in that case, I just want to thank you all for joining us today to explore the power and precision of AOS systems. Everett, are you saying something?
Yes, just one thing. That was very informative, Steve. and I hope all the attendees did see it as a valuable webinar. And also, but just one thing to expound or clarify, Steve, the coordinate system, right?
Yep.
We can get all coordinate systems that are available, right?
Yeah, your coordinate systems are all going to be controlled by the app that you're using. The data that's coming from EOS Tools Pro to that app depends on the correction source that you're using. So for instance, if you're using SBAS, then it's going to be an ITRF or WGS84. There's roughly 3 centimeters difference between the two. If you're using a RTK correction source, like a network RTK of some type, then the GPS is then going to be matching what that correction source is. So for instance, in Canada, in North America, it's CSRS is what the reference frame is. So it's important for you to know what you're correcting your data by. If it's just autonomous GPS, then it'll also be WGS84. So if it wasn't being corrected by WAS or anything like that, but, yeah. And then how it's displayed in EOS Tools Pro, we can show it as UTM, decimal degrees or decimal degrees seconds, decimal minutes seconds, something like that. So there's various ways we can display the information. In all the examples you saw decimal degrees. And then from there, again, it's the software that you're using or the app that you're using as to what the actual coordinate system for the map is.
Okay, thanks much. And also the accuracy, right? The accuracy that can be achieved is down to 1 centimeter depending on the type of equipment that is purchased, right?
Correct. The equipment. So if you're using single frequency, like a 100 series, whether it's Scotty or Arrow, the rating is 30 to 60 centimeters. If you're using an RTK enabled unit, it's also 30 to 60 centimeters when using WAS or EGNOS, some type of wide area augmented system. But with the RTK models, you have the ability to connect to an RTK source and get that down to your 1 to 2 centimeter accuracy. And that's X, Y, and Z.
Okay. And the RTK models start from the Scotty 200?
Or the Arrow 200, yes.
Okay, thanks for that.
Before I close off, Evan, are you sure there's nothing else you'd like to ask Steve?
No,
Evan?
I'm fine with those.
Okay. So since I'm not seeing any questions and Everett has confirmed that he has absorbed as much information as he can from Steve at this time, I just want to thank everyone for joining us today to explore the power and precision of EOS GNSS receivers. We hope this session has given you valuable insights into how EOS positioning systems is advanced and advancing geospatial data collection through innovative high-performance technology. I just want to say a special thanks to Steve for sharing his expertise and industry experience with us. Your insights truly highlighted the versatility and reliability of the SCADI and our series receivers. So whether you're working in GIS surveying or UAV data collection, we encourage you to consider how EOS solutions can elevate the accuracy and efficiency of your fieldwork. So stay connected with us for more updates, training opportunities, and events designed to help you maximize your geospatial capabilities. Have a great day, and we look forward to seeing you at our future sessions.
Thank you so much, Kamisa. Thanks, Ever. You guys have a great afternoon.
Yeah, thanks again, Steve.